Assalamu alaikum, guys. Today, inshallah, we are going to discuss frequency distribution and graph in chapter 2. Lecture 3 is first lecture in chapter 2. We already finished chapter 1, the first two lectures. First lecture with give definition of statistics. And we discuss about data. We classify data to two types, qualitative type of data and quantitative type of data. Quantitative type of data, we also divide it to discrete and continuous. Then we move to level of measurements. We also discuss about the four levels of measurements: nominal, ordinal, interval, and ratio. The second class was about sampling techniques. We discuss the main four sampling technique: simple random sample, systematic sampling, stratified sampling, and clustering sampling. We also discuss about type of studies. We discuss the two types of studies: observational studies and experimental studies. Now we already finished about the first step of statistics, which is collecting of data. We know what is data and how to collect data. And now we already have data. So we have to move to the second step in statistics, which is organization of data. So this chapter discuss about how to organize data. We organize data in two methods. There is frequency distributions and then graph. This class, inshallah, we are going to discuss about how to organize data by using frequency distributions. So by ending of this class, you will learn how to organize qualitative data using categorical frequency distribution, and also organize quantitative data using group or ungroup frequency distribution. So we know we have two types of data: qualitative type of data. In this case, in this type of data, we use categorical frequency distribution. In the second type of data, which is quantitative type of data, we use group or ungroup. Inshallah, we'll discuss in which case we can use group and in which case we can use ungroup frequency distribution. After collecting the data, the researcher must organize it in a meaningful way so that it is possible to get a general overview of the result. Of course, if we can organize our data in a meaningful, it will be easy to be overview and easy to be understood by interested readers. So simple one method for simplifying or organizing the data is to construct frequency distribution. This is what we will discuss in this class, inshallah, frequency distribution. So what is frequency distribution? It's a summary display for distribution of data. This frequency distribution actually consists of two columns. First column, we called it classes. Second column, we called it frequency. So what is frequency? Frequency characterizes the number of time of how often category, score, or range of scores happened. For categorical, we talk about category. For ungroup, we talk about score. For group, we talk about range. So frequency is number associated with each class or category. There are different types of frequency distribution to choose from, depending on if the data is categorical, quantitative, non-numeric. In this case, we use categorical frequency distribution. If our data is quantitative, numeric data, we have two options. We can use group or we can use ungroup according to specific criteria. We'll see later. So now we have three types of frequency distribution. The first type is categorical frequency distribution. We use this with qualitative type of data. The second and the third type of frequency distribution we use with quantitative type of data, which is numeric data, discrete or continuous. In this case, we have to use group or ungroup. Raw data. This raw data is the collected data in the original form before we organize it in frequency distribution. We will start with the first type of frequency distribution, which is categorical frequency distribution. Categorical frequency distribution is used to organize qualitative data. So as we mentioned, if our data is qualitative type of data, in this case, we use categorical frequency distribution. Qualitative type of data, as we know, non-numeric data, political affiliation, religions, affiliation, majors, field of study, marital status, gender, and so on. In this case, we use categorical frequency distribution. So categorical frequency distribution consists of 4 columns. Column 1 is classes. Then we construct tally. This from all this from raw data, and then we construct frequency. Then we move to percent. Frequency distribution in general, initially consisting of only 2 columns. First column is classes, and second column is frequency. Tally, we use tally to compute frequency. Percent, we compute it from frequency. So there is, we have to construct classes and frequency. From where we constructed? From that raw data. From raw data, we construct classes and we compute the frequency. Let's take this step how to construct, but let's go to example and explain how can we construct a categorical frequency distribution. This example, first example in chapter 2, in page 43. The data below is raw data, represent the plot type of 25 people, say 25 students, for example. So plot type is qualitative type of data. So which type of frequency distribution could be used? Yes, we can use the categorical frequency distribution with this qualitative type of data. How to construct it? Just first step, we come and see the categories in our data. How many categories we have? A, B, O, and AB. So we have 4 categories. We go to first column, we write classes. In classes we write A, B, O, AB. We have 4 categories. Column 2 is tally. Tally just help us in compute the frequency. But because we have only 25, maybe just we can directly go to frequency and find how many A we have. How many A we have, just we compute 1, 2, 3, 4, 5. Just we write 5 with A. B, how many B we have? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 7. 7, B. How many O we have? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. One category remaining is AB. How many AB we have? 1, 2, 3, 4. So we have 4. Just make sure summation is equal to 25. 12 plus 9 is 12 plus 12 plus 9 is, so we miss 12 plus 9 is 21, 26. So we have one mistake. We repeated one. Just check AB. 1, 2, 3, 4. AB is 4, 4. So now it's 12, 21, 25. So we are right. Just see. Yeah, we write AB. Order is not important. You can start it from O, B, A, B. It's okay. No problem. And this category 5, 5A, 9O, 7B, and 4AB. This 9, we have to add this 9. We have to delete this mistake. So tally just to compute 1, 2, 3, 4, and close is 5. Each bucket is 5 number. Now we go to compute the percent. Percent is this frequency over total number of frequency multiply by 100 over 25 multiply 100% equal 20%. 9 over 25 multiply 100% is 36%. 7 over 25 multiply 100% is equal to 28%. 4 over 25 multiplied by 100% is equal to 16%. Summation of this definitely equal 100%. Or approximately 100%. Here we get it 100%, maybe because of 25 is the number of the sample size. We have activity page 44. We asked 30 employees from a company if they are satisfied with their current job. So this is qualitative type of data. The response of this employee are recorded. So where very represent very satisfied, somewhat means somewhat, and none means I stand for not satisfied at all. So we have 3 categories which are very somewhat and none. So we go to the first column, we write classes and write first category is very, second is somewhat, third is none. Very, very, some, none. Then we move to find how many. This help us to find this. How many very, how many some, how many none. Let's go back and try to find 1, 2, for very 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 for employee, those responded with very satisfied. 1, 2, 3, 4, we close, it's 5. 1, 2, 3, 4, 5. We're supposed to find this first, then this, because here it is easy, we get this, then we can write this sum. How many? Somewhat response 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15 maybe. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. Sum is 14. 1, 2, 3, 4. It's 5. 1, 2, 3, 4. It's 5. 1, 2, 3, 4. So we have 5 plus 5 plus 4 is 14. None. Yes, none is not much. None. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6. So here we have 6. 1, 2, 3, 4, 5, and 1. Percent just total. We make sure summation is 30, as mentioned in the example. There are 30 employees. So if 29 we miss 1, if 31 we replicate 1. So now percent is 10 over the total number multiplied by 100%. It's equal maybe about 33.3. 14 over 30 multiply 100% is equal about 47.67. 6 over 30 multiply 100%, this is 20%. So total of is like 99.9. It's approximately 100%. It's all about categorical frequency distribution. Now we are moving to the second type, which is grouped and ungrouped frequency distribution. Let's see when we use group and when we use ungroup. we use group frequency distribution if the range of data is large. Large means like less than, greater than 10. In this case, we use grouped frequency distribution. If range is small, 10 or less, in this case, we use ungrouped frequency distribution. Okay, so our quantitative type of data, we can use two types according to range. If range is large, we use group frequency distribution. If range is small, we use ungrouped frequency distribution. We started with the grouped frequency distribution. As we mentioned, frequency distribution in general, consisting of only two main columns, column 1 classes or column 2 frequency. From these two columns, we can generate other columns. From classes, we can generate class widths, class midpoint, class boundaries, and class limits. For frequency, we can generate or produce relative frequency. Also, we can produce cumulative frequency. Let's see how to construct group frequency distribution. Let's start with example. Before I started with example, let's see the rules that we have to use when constructing group frequency distribution. Classes should be between 5 to 10 to 20. And it's preferred, but not absolutely necessary, that preferable, but not absolutely necessary that the class widths be odd number. It could be even, but we prefer it to be odd. Class must be mutually exclusive, no overlapping between classes. So given that a value can fall into only one class, is no overlapping. This will be clear, inshallah, after we see how to construct the frequency table and what we mean by overlapping. Also, classes, all data sets should be accumulated at the classes. Also, we'll see how this will be. Also, class widths should be uniform. Let's see example and explain how to construct the classes, how to construct the frequency, how to generate some columns from classes column and some columns from frequency, and also will explain what is widths and class midpoint, class limits, class boundaries, and also will explain the rules of constructing frequency grouped frequency distribution. So now we have example 3, page 46, study done on 50 students participating volleyball at university, including question about their height. So we ask them about their height in centimeters. Student height in centimeters, 176, 166, and so on. So we have 50 students, and this is their height. Question is construct frequency distribution using 5 classes. Just we ask you to construct frequency distribution. He don't mention group and group, categorical, no. So just we come and visit quantitative? Yes. So it could be group or ungroup. How to decide it? Is it group or ungroup? We come to find the range. So first step, we find range. Range is max point minus minimum point. So this is the maximum one. Minimum, the shorter one is 150. So range is 29. So in this case, we use group frequency distribution. Step 2, we find width equal range over number of classes. Number of classes always given. So as I asked, number of classes. So it is 29 over 5. So approximately it is 5.8. So notes, we have to round it up, always up. Even if we don't have fraction, also we need to round it up. So our width is 6. Now we go to construct our classes. We started with the minimum value, which is 150. Then we keep adding our width is 6. 6 is 162. 6, 168. 1, 70. We add 6, 74. Yes, we call it lower limit. It's first class, second class, third class, fourth class. This is the fifth class. As they ask us to construct frequency distribution using fifth class, so now we have 5 classes. This is lower. How to find the upper limit? Yes. Here we have 156. Just we subtract 1 and start it with 155. 155. Then we keep adding 6. Same. We add 6. We add 6. 161. We add 6. 167. We add 6. 173. We add 6 is 179. So now we constructed the class limits. From where? From the raw data. So now from this column, we can construct class boundaries, class midpoint. Let's see how. For class boundaries, just we subtract 0.5 from the lower and we add 0.5 to the upper. So 150 become 149.5. 155 become 155.5, and so on. Same, we subtract minus 0.5 from the lower and we add 0.5 for the upper to get this class boundaries. Class boundaries, inshallah, we'll use it later because now it become like continuous. We finish with 155.5. We started the second class with 155.5, same, so it become like continuous. Here we finish with 155, but we start with 156. So we have gap 1 point. For the midpoint, just we add the lower class plus the upper class over 2. So 150 plus 155 is 200. 305 over 2 is 152.5. Then just we can keep adding. We can keep adding 5. Just we can keep adding the width, which is 6, 6, 6. We can keep adding 6, 6, 6, 6, and 6. Instead of use same idea, plus over 2, plus over 2, plus over this long story. Just we get the first one, then we keep add 6. Keep add 6. Why 6? Because 6 is the width. Also, midpoint can be computed from the class boundaries plus over 2. We get same. So just we need to get the first one, and then we keep adding class widths in order to get the others. Now we finish compute all classes that could be computed from the class limit. Now we're going to construct the second main column, which is frequency. Frequency, we go to our raw data and compute how many numbers between 150 and 155, including 150 and 155. Let's go back and compute how many number between 150, this one, 2, 3, 4, 5. So 5, 1, 2, 3. Also, we have 1, 6. So 150 included 151, 152, 153, 154 till 155. So we have 6. We go and write 6 for the first class. First class frequency is 6. First class frequency is 6. Then we do same. We go to our raw data and compute how many numbers or how many values between 156 and 161, including 156 and 161. We started when 156, 157, 158, 159, 160, 161. Same idea. So we get it 3, 7, and 14, and 15. Also, we have to make sure summation of this frequency equal 50. It's 9. 9 plus 7 is 16. 16 plus 14 is 30. 30 plus 20 is 25. So we are right. Now we're going to compute the relative frequency. How to compute relative frequency? Just same like when we compute the percent for the categorical frequency distribution. Just we don't multiply by 100. So it's 6 over 50 equal 0.12. 3 over 50 equal 0.06. 7 over 50 equal 14 over 50 equal 0.28, 20 over 50 equal 0.4. Summation should be equal 1 or approximately 1. So this is 18, right? 0.18 plus 14 is 0.22 and 0.28 is 0.32, 0.28 is 60, 60 plus 0.4, 0.6 plus 0.4 is 1. Yes, it is 1. Now moving to construct the last column, which is cumulative frequency distribution. Cumulative means like the first depend on the first. First is first, like your GPA first semesters is just depend on your performance in first semesters. So 66. For the second semester, for the second classes, we add this cumulatively. This 9, 8, sorry, this 8. Then we take this. This no, it's 9. Oh, it's 9, 3. 6 plus 3 is 9. 6 plus 3 plus 7 is 16. Then we add 14. 14 is 30. Then we add 20, so it's 50. This should be 50. So the last cumulative frequency of the last classes should be equal the number of observations. So it's clear, 1 is 1. For the second, we add the second, we get the second, we add the third, we get the third, we add the fourth, we add the last, we get the last. So it like this. So now we have activity page 50. We already have group bit frequency distribution already constructed, and some item is missing. Yes, we need to find the value of these values. So this class limits, how to get class limit, we started with the first point, then we keep adding the which is 5, so we keep at 5, 5, 5. So this is 13. This is 18. And then we keep 23 is then 28. Same idea, we keep adding 5, 17, 5 is 22, and make sure this 22, this 23, this 17, this 18, this 12, this 13. So we are right. This class boundar, how to get class counter? We subtract 0.5, we add 0.5. So it's 2.5 to 7.5. Also, class boundar is continuous. So this 12.5, also this should be 12.5. Also, we keep adding 5 because our width is 5, 17.5. 17.5, this should be also 17.5. This 22.5, this also should be 22.5. 0.5. So now we finish the class boundary. We move into class midpoint. Class midpoint, as we mentioned, we just need to find the first one, and then we keep adding class widths. Width is 5. It's very helpful. So just we add 5, 5, 5, 5 is 25. So now we finish all column related to class limits, moving to class frequency. We have 40 number of observation. With this missing, it's easy to be get it. Just we compute total of this subtracted from 40, we get it, it's 14. But if 2 or 3 is, for example, if this is not available and also this not available, you can get it from this. Because we get this from where? We get this by divide 5 over 40. We get 0.125. So if this given and this given and this missing, just we get it by multiplication of 0.125 multiplied by 40. So if this missing, we just get it by this equal 40 multiplied by 0.125. So we need to know the relation between these two columns. Give you this, you know how to get this. Give you this, you should know how to get this. So now how to get I, same idea. I means 2 over 40. 2 over 40. J also 8 over 40. You get J. Last column, how to get the last column? 3 is 3. 8 we come to this 5. 3 plus 5 equal 8. 8 plus 2 equal 10. 10 plus 8 equal 18. 18 plus 14 equal 32. 32 plus 8 equal 40. 40 is the total number of observations. So we are right. We have to know how to find this from this or this from this. So we have to know the relation between relative frequency and the relation also between cumulative frequency and frequency, also cumulative frequency and relative frequency. So also we have activity for the ruling of constructing frequency distribution. Statewide for frequency distribution below are incorrectly. So we have some rules. First rule, number of classes should be less than 20. Yes, of course, all this less than 20. Then class should be uniform. Class width should be uniform. Here is, we add 6, but here we add 5. So width is not uniform. Not uniform. This is why this is incorrect. Let's see the second one. Second one, we finished with 9. We also started with 9. This we called it overlapping. Why overlapping? Because 9 is computed in this class. Also computed in this class. 13 computed in this class and also computed in this class. So this make it overlapping. So see here we have overlapping. Let's see, we have we add 5, 4. We add 3. Also here we have plus overlapping. We have class is not uniform. Let's see the third one. Third one we add 5. Here we add 10. Actually, we have omitted classes. One class is not available here, which is from 133 to 137. This also makes this frequency distribution incorrect. Let's see the third one, the last one. Here we add 5. Here we add 6. So class is not uniform. Now we are moving to see the last type of frequency distribution, which is ungrouped frequency distribution. Our data still is quantitative type of data, but the range is small, less than 10. So in this case, we use ungrouped frequency distribution. Initially, we use it with discrete type of data. Also simple, just like categorical frequency distribution. Compute the classes. Actually, class consists of one item, 1 point, not range. So we don't need to find class boundaries. We don't need to find class midpoint. Actually, have 1 point. Frequency, from frequency, still we can find relative frequency, and still we can find cumulative frequency. Let's take example. We have the quality control department examine 20 engine, which they selected randomly from manufacturing company that are given below, show the number of defective circuit per engine. So no defective, 0, 1 defective, 2 defective, 3 defective, and 4 defective. Maximum is 4, minimum is 0. So range equal 4. 4 is small range. In this case, we use ungroup. How to use ungroup? Yes, we construct. Let's see how. Like this, just classes, just like categories. We use like A, B, O. It's like this. We use 0, 1, 2, 3, and 4. This is our 5 categories for classes. That's why we call it ungroup. Ungroup because we don't have range. That's single value. So how many zeros? We have 3 zeros. This 3 engine without any defective, 4 with 1, 6 with 2, and 4 engine with 3 defective, and 3 with 4 defective circuit. From here, we can construct relative frequency by dividing this frequency over the total number of frequency. 3 over 20, we get 0.15. 4 over 20, 6 over 20, and 4 over 20 equal 0.2, or 3 over 20 also equal 0.15. Summation of relative frequency equal 1. Cumulative frequency, as we mentioned, 1 is 1. 1 is 1. For 2, we add this with this, we get this. This with this, we get this. 13 with 4 plus 4 is 17. 17 plus 3 is 20. 20 is the total number of observation, which is same like summation of frequency. So this is how to construct ungroup ungroup frequency distribution. Ungroup because we have one single value, we don't have range. If we have range, it is group. So we have other example. We asked 24 students, 5 general knowledge question. The number of correct answer given by each student are shown below. Correct, one student answer 4 question correctly, 1 mistake, 2, 3 mistake, 3 correct, 2 mistakes, 1 get all correct. So we go to find there is it's clear range is small because actually we have only 5 questions. So range is small, but it's 5 minus 0 equal 5, so small range. So we have to use ungroup frequency distribution. This is group 1, group 2, group 3, group 4, and group 5. So we have 5 groups. Oh, we have to solve this. Okay, so we start with classes 0, 1, 2, 3, and 4, and 5. We have 6 classes. We go to find frequency associated with each value. How many 0 we have? 1. How many 1 we have? 1, 2, 3. 3. How many 2 we have? 1, 2, 3, 4, 5. How many 3 we have? 1, 2, 3, 4, 5, 6. How many 4 we have? 1, 2, 3, 4, 4. How many 5 we have? 1, 2, 3, 4. 4. So just make sure summation should be 25, 24 as mentioned, 24 students. So this is 4, 9, 15, 19, 23. We miss 1. We miss 1. Let how many 4? 1, 2, 3, 4. Yes. 4. How many 5? 1, 2, 3, 4, 5. So it's 5, not 4. Summation is 24. So we are right. We move to find frequency, relative frequency, RF, relative frequency. 1 over 24. Yes, we use calculators. 1 over 24. 3 over 24. 5 over 24. 6 over 24. 4 over 24. 5 over 24. Summation, of course, equal 24 over 24 equal 1. Summation of relative frequency equal 1. We move to compute the cumulative frequency. When is 1, then 1 plus 2 is 3. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 4 is 19. 19 plus 5 is 24. 24 is 24. So we are right. Now we finish constructing the ungroup frequency distribution for this table. Now we have some questions. When data are collected in original form, they are called what? Original form before organizing the data, we called it, of course, raw data. The hash of a specific class associated with class is the number of the data values contained in this class. The number of the value for a specific class. The number, how many values contained in this class. Like, for example, a range 150 to 155, it was 6. How many 0? It was 1. So it is this frequency. The frequency of a specific class is the number of data values contained in it. Zahra want to construct a frequency distribution for the education level of the employee at Aramco company. What type of distribution would be the best? So Zahra want to construct frequency distribution for what? For education level. Education level is qualitative type of data. So in this case, we have to use categorical frequency distribution. Actually, this is ordinal. So for ordinal and for nominal, we use categorical frequency distribution. But if Zahra want to construct frequency distribution for age of employee, in this case, she has to use grouped, because age of employee is supposed to be range, large range, but age of student may be small. What are the boundaries of the class? If we have classes like this, so just as we study in first class, for boundary, we see this last value. This is 7, it's like 70. We subtract 0.5. So we put it 65. So just 1.8 instead of 70, 65. We move to this is 30. We add 5, become 35. So 3.4 instead of 30, we write 35. So it is this one. What is the midpoint of the class? This class limit is lower, and this is the upper. So how to find the midpoint? Yes, we add lower plus upper over 2. This 29 over 2 is 14.5. So this is the midpoint of this class. So we finish, inshallah. We see you in face-to-face class by Sunday classes to solve worksheet. Assalamu alaikum.